right, Precalc, we're moving on to the second half of lesson 2.2, moving slowly but surely. We are moving on to how to write polynomial functions when you're given zeros. A lot of people forget this lesson. So again, it is probably something that I would star, circle, highlight, and just know that we can do this. There are a few ways to do this. The first way is I know that if I had to write these numbers as a set of factors, it would be x plus 2, x plus 2, and then remember to get this, let's think about it. If I had this and I was solving for x, I would bring the 1 over and I would divide by 2. So remember that 4 in this case is going to go in front. Because it is positive, I'm going to make it negative. And now if I was to solve 4x minus 3 equals 0, I would get that. You can FOIL this all out. That is fine, starting with the first. But remember that we've had this little formula that we used last year. X squared minus blank x plus blank, where this was the sum and this was the product. And this is a lot easier, especially when we get to problems like B. But right now we're going to look at A. And if I was to plug these numbers in, I would take these two numbers, -2 and -2, and I would add them up. They add up to be -4. Oh, look, that will be added. I would multiply them. That gives me a +4. So notice I just did this foiling without actually have to going through all of that. So now I can take 4x minus 3 and distribute it through x squared plus 4x plus 4. And I'll show you why I like to use this. I'm going to write it again. Let's distribute the 4x through. I'm going to show you why I like that on the next slide. 4x times x squared is 4x cubed. 4x times 4x is 16x squared. 4x times 4 is 16x. All right, now I'm going to distribute this -3 through. -3 times x squared is -3x squared. -3 times +4x is -12x. And -3 times 4 is -12. So when I add these all down, I'm a visual person, so I like to just add down. It's fine if you like to show it all in one line. I got 4x cubed plus 13x squared plus 4x minus 12. And no matter how you do this, if you go ahead and write out the factors like I showed you here and FOIL these all through, you'll get the exact same answer for example A. Now, the reason why I like that formula is it's a little harder to do it this way when you're foiling. So let's go back to that formula. That's x squared minus the sum of x plus the product. Now, if I had to, I would choose these two. Because I know when I add a √5 and a -5, I get 0. And I know when I multiply √5 and -5, I get -√25, which is -5. So this is going to be x squared minus 5. And then to make that into a factor, we would just write x minus 1. And again, I would FOIL. First terms, x cubed. X squared times -1 is -x squared. And -5 times x is -5x. And -5 times -1 is +5. So the answer to these three right here is x cubed minus x squared minus 5x plus 5. So this is where we're going to use no calculator because they're telling us to graph this by hand. And this is where we're going to use the leading coefficient test. So the leading coefficient is a even. It's also a positive number. So I'm going to think of that x squared parabola. So I know that it is going up and up. Now, they're telling us to find the real zeros. Please excuse my sloppy notes. I should have done a little bit better. I can take out an x cubed here. And when I take that out, I have 3x minus 4 left over. So I know my zeros right here are 0. And I know my zeros over here are 4 over 3. So I'm going to start by graphing what I do know, okay? I know that I need a Cartesian coordinate system. I know that I have a 0. Well, let me go ahead and draw some little points here. I know that I have a 0 at 0 and another one at 4/3, which is 1 1/3. I also know the leading coefficient test tells me it's going to go up, up, and I'll probably eventually erase those because I'm going to show a different graph. But the next thing says to plot some points. Well, I've lost my graph, or my equation. My equation was f of x equals 3x to the 4th minus 4x cubed. This is what we're working with. Now, the hard part, well, let's go ahead and let's plug in 1 first. If I plug in 1, 3 times 1 to the 4th power minus 4 times 1 to the 3rd power is going to be -1. So at 1, I'm also going to have -1. It'd probably be smart to graph this little halvesy to see what's happening. Not really convenient, but we could figure it out. If I had to plug in 0.5 or 1/2, could we figure that out? All right, so I started showing some work right here. We end up getting 3/16 minus 1/2. Well, 1/2 is equivalent to 8 over 16. So if I have 3 over 16 minus 8 over 16, which is -5 over 16. Yes, that's a weird number, but we're smart. We could deal with this. So I know that at a half, I'm going to be at -8 or -5 over 16, which is not quite a half, but it's going to be about here. Okay. Well, we know if I plug in a number 2, it's going to skyrocket because I have 3 times, well, 2 to the 4th power is 16. And 2 to the 3rd power is 8. So this is where it's going to kind of skyrocket. So I'm going to graph it in pink. I know that this is going up. I know this kind of has a weird dip. And I know this is going up. Remember I told you I would erase these little blue lines. So I'm guessing the graph of this is going to look with this little dip right here. It's going to be a little uneven, but it's still going to be a function. Plug it in your TI, and let's see if we were right. I'm going to show you that graph again so you could plug it into your TI. Let's see if we're right.